Hello, welcome to CSC7132, Operating Systems and Networking. This is Brady Chen. In Module 8, we're going to talk about a file system. Now, file system is part of the storage in a computer system. Now, a computer system has many different storages. Okay, so to execute a program, to actually execute the program, you first need to copy the program into the hard disk. Hard disk is a storage. And then to execute the program, you have to copy the program from the hard disk into the computer memory, the main memory. And then memory is another storage. Okay, now to actually run the program, so then operating system need to load the instructions in this process into the computer CPU and store in a register. Now register is a storage in the CPU. So then we can basically organize the computer storages into a hierarchical structure. Okay, like a pyramid. Now on top of this pyramid, it's the register. Register is actually located in the CPU or processor, computer processor. And then another storage, which is a little bit slower than the register, is the cache, which basically store the temporary data. And then below the cache, that's the main memory. And then it's like a hard disk. The fastest the storage hard disk is something called SSD, the solid state drive. And then we have a magnetical disk. That's the hard disk, right? That's something we use normally in a computer system. Something slower than hard disk is the optical disk, such as CD, DVD. And then below the optical is the magnetic tape. Okay. Now, if you look at this pyramid, the top one, the register, is the fastest one, the fastest storage, and the bottom one is the slowest. So when you actually go down the pyramid from the top, the access speed is getting slower. And when you go up, it's getting faster. Now, in the meantime, the register is also the smallest storage. It's fastest, but it's smallest. And then cache is bigger. Memory is much bigger, okay? But memory is much slower. So in this hierarchical structure, so once you go down the pyramid, it gets bigger. And it gets smaller once it go up. Okay, so that's the structure. So now we have talked about memory management. Memory management is part of the operating system that manages the main memory. Okay, the process, in the earlier modules, we talk about the process, right? Process actually basically talk about how to, how could the operating system, schedule the process, which process get the CPU, and which process should be removed from CPU. Okay, so now in module 8, we're going to talk about the file system. So basically, we're going to talk about the operating system, the part of the operating system that manages the storage space below the main memory below this period mode. And there's a line in this period mode. All the storage above this line are basically called volatile storage. And below that dashed line is called a non-volatile storage. Now the difference between these two storage is the volatile storage is gonna lose its data when you turn off the power. But non-volatile storage, you can actually turn off the power and the data still actually stored in the storage. When you turn the power back on, then the data stored in the non-volatile storage are still there, like SSD, magnetic disk, the hard disk. So you can actually copy the file into the hard disk, and you're never going to lose the data. Okay. So let's talk about the file system. Okay, so what is a file system? A file system is an integral part of every operating system. So it is part of an operating system. Now the function of the file system is to implement the concept of files. Now what is a file? A program that is stored in the computer hard disk, that's a file. A data is a file. So some kind of executable file, program, that's a file, right? So file is a named collection of information managed on the secondary storage by the file system. Now, what is secondary storage? The non-volatile storage. These are secondary storage. We just mentioned storage. Now, when the data or program stored in the secondary storage, there are various different formats because depending on the medium of the storage. Now, for the solid state drive, you can store the data in certain format as a binary digitals, right? And then in the magnetic disk, you can store the data, in another electronic format. So now the purpose of the file system is to provide some kind of a view that allow the user to view the file as a single abstract unit of data storage and access the file contents using high-level operations provided by file system interface. Okay, it doesn't matter how the file is stored in the hard disk or the storage medium. Now, the file system in the operating system can provide an interface, allow the people to provide some kind of logical view of the data. Now, that logical view is the file. Okay. So the user can actually access the data through the file system interface without knowing the specific characteristic of the underlying storage devices. Okay. So when you try to see a Microsoft Word document in a computer system, what are you going to do? You're going to actually open the operating system, Windows, and you click the icons. You use the, you view the Windows data. Okay, you are not going to open the case and take the hard disk out and try to figure out, what the data, where the data is stored. You don't have to do this. You don't need to even know the ugly side of the hard disk. Okay, so that's the file system. It provides some kind of, abstract view of the data, okay, called a file. So depending on the type of file system, a file can be viewed as an unstructured string of bytes or a series of records. So eventually, the file is going to be stored as the binary digitals, right, at the very bottom. So, but So the file system can organize this file into unstructured string of bytes and a series of records. Now, what is a recorder? A recorder is a structure of related data items, possibly of different data types, so identified within a file by a record number or unique key field. Okay, so we can talk about this a little bit later. Okay. Now, to manipulate the files in the file system, the operating system provides a set of operations called an access method. The access method serves as part of the user interface to access files. Now, the file system presents a logical view of files to the users. Okay, so for example, we have 3 different files: file A, file B, file C. These files may have different structures, but the file system presents a logical view to the users to make all these files look similar. Okay, and then also the file system provides a uniform interface to the file. For example, it provides a method like a create, locate, and delete. Even though the different files have different structures underneath, so the actual implementation of the create or locate are different, but they use the same uniform interface. Okay, so now certain operating systems present files as unstructured string of data. Now, these unstructured string of data can be accessed sequentially. Now, the operations to access this unstructured string of data are called byte string oriented operations. Okay, so in this case, the operating system maintains the current position. Okay, maintains the current position in the file, and then a read write command. The read write actually command always access the next m bytes. So that's the reason why it's called a byte string oriented operation. So when you call the read or write command, so you're going to provide the next n byte. For example, if n equals 100, so then the read and write can actually, read the next 100 bytes or write the 100 bytes, next 100 bytes. Okay. So its current positions here, and after n bytes, the operating system is going to move to this position. Okay. So also, to allow direct access, a seek command is used. A seek command moves the current position from the current position to directly move the position from current position to position K, for example. Okay, so then it just move directly to here. Here's the K. Okay. Now, in previous slides, we mentioned that the certain operating systems support files as unstructured strings of data. Now, these unstructured strings of data can be accessed sequentially using the byte string oriented operations. Byte string oriented operation. For example, if you can use read or write next n bytes. Okay, so if the current position is here, then read or write the n bytes will move the position to here. And then you can also use the seek to position K command to directly move the position to K, to position K. Now, certain operating systems support files as sequence of fixed length records. Okay, so for example, like file B, the files is actually organized as a fixed length record, and they have the same length. So this is a record 0, record 1, record 2, record 3, that we have all the way to record M. Okay, and now the operating system currently point to the position, to point to the record M. Okay, so the sequential access is supported in this case by maintaining the current position similar to the byte stream, but in this case it's not a byte, it's record. Okay, so then you can use some kind of called a sequential record oriented operation. Okay, so to access the data in a file. So in this sequential record oriented operation, they still use the same command, also called read and write. Okay, but in this case, the read and write command is gonna actually just perform on a record. So you're gonna use read and write next record. Okay, so instead of next 100 bytes, now you actually call the read and write operation to to access the next record. So for in this example, once the read and write next record is called, then the operating system is going to point to the next position or next record. Okay. Now, the fixed length recorder files, like a file B, fixed length recorder files. Okay, here's a record 0, 1, 2, 3, 4, 5, all the way to N. That's a recorder N. Okay, so the fixed length recorder files also support the direct access. Okay, because the starting position of any recorder K, for example, if I have a recorder K, the starting position of the recorder K can be calculated by multiply the K by record length. Okay, here's the recorder K. Okay, the starting position of the recorder K. You start from the recorder 0, right? So to calculate this position, you find out there's a total of K records. Now each record, the length of the record, the K records times the length of record, it just gives you the position of this particular recorder K, the starting point of the recorder K. So you can use the direct access for the fixed length files. Okay, so in this case, so you have byte string oriented. Okay, so sequential record oriented, or then you can use the direct record oriented. Okay, you can also do that. Okay, so we just talked about the operating systems which support the files as an unstructured string of data. We can use a sequential access or just direct access, right? Like this case file A. So it's unstructured strings of data. So you use the read, write, like a next in bytes, okay? And you can also use the seek to position K, right? Now, for the fixed length files, like a record 012 and M, then record M, then we can also use the sequential access. And we can also use the direct access, because you can just multiply the record number by the length of each record. Then you can directly jump to the particular record. Now, what about files stored as a variable length records? Okay, so then the file has a variable length record. So here's a record, and here's another record. Okay, so the record has a different length. So in that case, you need a certain space to record the length of this record. Okay, so here's the record 0. Okay, so the length is L0. Okay, so the length 1 for the recorder number 1, and the length 2 for the recorder 2, and for a length record I, you have a length I. Okay, so each defines the length of the record. Okay, so with variable length records, each record starts with the record length I. Okay. Okay. Now, sequential access is supported by advancing the pointers by Li. So, for example, currently it's pointing to here. Now, what's the next position? So you're going to move to, the length of, in this particular case, L1. You're going to move the length of L1 to the next position. So that's the second record, third record 2, right? So the first recorder is recorder 0, recorder 1, recorder 2, and that's record Li, that's record I. Okay, now in that scenario, there's no way you can perform the direct access, right? Because each record has various different lengths. You have to start from the recorder 0 and then move the L0, the length of L0, and then you move to L1, and then move the length of L1. Then you move to recorder 2, and then you move to the recorder 3 by moving the length of L2. So you're going to move each record by record. You cannot directly jump because you have no idea what's the length of each of the record. Okay. Okay, let's summarize what we have talked about. We have 3 different files. The files as an unstructured strings of data, the files as fixed length record, and a variable length of record. And we also talk about the various different access operations that to access various different file type. Okay, for the first case, like a file A, you can use sequential access and the direct access, right? File B can also use the sequential access and direct access, but it just actually use the record instead of bytes. Now, for variable length file, like a file C, then only the sequential access is supported. Now, at the bottom line is the file system manages all files on the disk using low-level read and write operation. Okay, so here these read and write operations are at the high level. It's actually from user perspective, it provides a user interface. So user going to use the the command read or write. The user don't care what kind of structure each file is organized. Okay, but then the file system also manages all files on the disk using low-level read and write operations, and how a file is partitioned and stored on the disk is hidden from the user, and the user actually normally don't see this detailed implementation or the ugly part of this read and write command, because the underneath the storage medium is different. It could be a magnetic disk, it could be solid state drive, because they use different mediums, so the implementation is different, but these are hidden from the user. So that's the purpose for the operating system file system. Just hide the ugly side of these operations. Okay, so let's talk about the file types. Now, every file consists of data and the metadata. Okay, so the data is the portion of the file visible to the file's user. Okay, it stores the actual contents of for the file. Now, metadata is information about the format and the organization of a file's data, and generally stored in the file header. So a file contains the data and the metadata. And so the file header is a portion of the file preceding the actual data and is visible only to the file system itself. So this portion is not visible to the user. So it's in the file header. Okay. Now, a magical number is a short sequence of characters at the start of the file header. So at the start of the file header, there is a small space. They store a number called a magical number. Okay. Okay. Now, different file type has a different magical number. So then the file type in return determines which programs are allowed to access and interpret the files. Now, for example, like in Microsoft Office, you have a file type like a Microsoft Word, right? So then you can access the Microsoft Word file using the Microsoft Word app. So Excel spreadsheet, you can actually use Microsoft Excel to access this Excel spreadsheet. Okay. So the type is determined by a magical number. Now, many operating systems support the file extension. Now, file extension is another way to represent the file types. Okay. Now, the file extension is a sequence of one or more characters follow the file name. Okay. For example, if you have a file name called my file, then you can use the extension typically after the period, the dot, and then you can say doc. Okay, this is going to be this is an extension in the Microsoft operating system to represent a Microsoft Word document. Okay, a file extension is not hidden; it's visible within the file header, so it's actually on the file name, and thus can conveniently be examined by the users. Okay. Now, the file extension definitely has its advantage, but the user can easily see what type of file is this. For example, like many executable file use the file extension like say my file2.exe, which basically represent executable file. Okay. Now the drawback is that the file extension can easily be changed without changing the file's type. Okay, remember the file type using the magical number, it's actually in the header, the file header. The first one is magical number. That number is hidden from the user. So only the file system can access that number. So the user cannot change the file type if the file type is in the header. So, however, the file extension is actually, is extension for the file name. So the user can change the file extension. However, changing the file extension doesn't necessarily change the file type. So in the magical number cannot be changed. Okay, so if the magical number says, okay, so this is actually Microsoft Word file, and then the file extension should match it, right? Using DOC or DOCX using so this should match the magical number. But for some reason, the user base may accidentally change the extension from DOC to like Excel or PowerPoint. Okay. So that's the file extensions support only a weak form of file typing by providing convenient hints about the file type, but do not rigorously enforce what operations are valid for the given file type. So even though the file is Microsoft Word file, and then you change the file extension from .doc or .docx to .exe, so then people look at the file and they probably believe, oh, this is an executable file, so I can run this file. But this is still a Microsoft Word file, even though the extension says it's .exe. So that's why we call this file extension support only the weak form of file typing. Okay. So let's discuss the file extensions and the magical numbers using the example here. Now in this diagram, we have three files. The first file is a prog.c, and the second one is prog.o, and then prog.exe. Now we know that the prog.c typically it's the file contains the C language code. So normally we call this source code. In this case, it's a C language. Okay, and then after you compile the source code, you create the object code, and it's called the object module. And then using the linker, the object module and and the other library functions and data, so linked together to create the loader module. Okay. So the loader module was produced by a linker from object module. Okay. Now when you look at the loader module, so you can see the binary code which contains the instructions that's going to execute this program. And then you have program data and relocation information and other related tables. Okay. Now in the load module, there's a file header. Okay. The file header tells about the type of files and which program can actually, perform the operation on this particular load module. So, and at the very beginning, there's a magical number X. So this magical number X tells the operating system saying, this is an executable file. Okay. And then, as we say that the loader module was produced by linker from the object module. So object module also has a file header. It just tells about this is an object module, right? Tell the operating system about the type of this module. And also at the beginning of the file header, there's a magical number, which is not the same as the magical number X. It's a magical number Y. Okay. And then the object module was originally created, from the source module. After you compile the source module, you create the object module. So the source module also has the file header and also with the magical number Z. Okay. So now the type of a file is determined by the magical number, but also the file extension, many operating systems use the file extension to tell the type of the file. Okay. For example, program.c tells people that's the source code for C language. And .o, that means it's an object code after you compile the source code. And the .exe means this is executable, right? Okay. However, the file extension is not really, it's kind of vulnerable because the file extension is visible to the users. Unlike the file header, the magical numbers, the users cannot see the magical numbers, so the user cannot change the magical numbers. But the user can see the file extension, so the user can change the file extension. However, if the user changed the file extension from .c, for example, to prog.txt, it just changed the extension, file extension. It doesn't change the type of the file, so it doesn't change the magical number. It's still the magic number Z. So now what happens if you try to compile the prog.txt? Now this is going to cause some kind of trouble. Now it's dependent on the compiler. Now some of the compilers are very smart. Okay, so they actually compile the code. They don't just check the file extensions, say, oh, this is a program.txt, so I'm the C compiler, so I cannot do it. So some compilers they're smart. They don't look at the file extension, they also look at the magical number. And the magical number still tells the compiler, say, that's a source code, so you can compile it. So you can actually compile it and get the object code. Now some other compiler, they're not that smart. So in that case, they're going to actually generate the error message saying, okay, so this is not the source code. That's not a C code. So I cannot generate the object code. So it's pretty much up to the compiler. So that's why the file extension is kind of vulnerable. The user can change the file extensions, but this is going to actually confuse the people because the file extensions says it's a .txt file, so that's a text file, but it is not, okay? Because the magical number still says that's the C language source code. So you can also change the prog.exe to prog.c, and then when the compiler try to compile it, the compiler cannot recognize it because the file says, the magical number says this is executable. It's not a source code. It's not C language. So it's still going to actually cause some problem. So the file extension is basically, it's very vulnerable. So you must be actually use the file extension carefully. Thank you.